Students, we're talking about the MAC sublayers in the IEEE 802.11 standard. हम लोगों ने पहली MAC sublayer जो है उसकी बात की थी, the distributed coordination function. Students, the second one is an optional MAC sublayer. It is called the point coordination function, and that is present on top of the distributed coordinated function. And how we use is we actually use this for extremely time sensitive applications. And in this technique, what happens is that your access point, it actually continuously polls each one of the stations. So students, polling का concept जो है मैंने आपको wired के case में दिया था कि in this particular case, each of the stations is polled as if we are asking each of the stations if they have got any data that they want to send to the access point. So each of the stations, A is going to be polled first. If it's got any data, that will be sent. B is going to be polled second, then C, then D, and then A again. So we continuously keep on polling each of the stations that are in our wireless network. And if they've got any data to send as a result of the polling, they send this data. And students, this is a better technique in terms of the time that it takes than DCF. And this has got, when you have got a PCF acting in a particular wireless application in terms of a MAC sublayer, then we know that there are some applications, there are some transmission of stations that have got a higher priority to send as compared to others which are using DCF. Now, students, we'll talk about the frame format in this particular slide. As you can see, we have got in the wireless environment, because it is very noisy, because we are using air, because it's open to everybody else, a corrupt frame has to be retransmitted. So students, in this case, the protocol recommends a process which is called as fragmentation. And so what we do in fragmentation is we divide the large frames into multiple smaller frames, and it is more efficient to resend a smaller frame if it gets corrupted. Students, the MAC layer frame, it consists of 9 fields, as you can see on the slide. The first field, which is the FC field or the frame control field, is the most important one. It is 2 bytes long, and it defines the type of the frame and also the control information that we need to send. So students, let's first look at the FC field. Students, these are all the fields that we have in this frame control field of 2 bytes. The first one is a version number. You've got the type of information, whether this is an management frame, control frame, or data frame. We'll talk about that next, the different frame types. Then it has got the subtype of each type, and it is to DS and from DS. We'll talk about that in a little bit. Then you've got from a more flag. Set to 1 means more fragments are coming. Retry means it's a retransmitted frame. Then we've got some bits which are allocated to power management, WEP, which is wired equivalent privacy or encryption, that's implemented in the case of wireless. And then we've got some reserved bits as well, mostly for error detection as and when required. So students, coming back to our frame format, this is our first field or the FC field. Then you've got a D field, which defines the duration of the transmission that is used to set the value of the NAV. So students, मैंने आपको बताया था कि if this is part of a control frame or an RTS frame, there will be a mention of how long the sender intends to occupy the channel for. And this will be used by all the other impacted stations to set the value of network allocation vector. So then you have got 4 address fields, each of 6 bytes long. And in this particular field, we add some addresses. We'll talk about that to DS and from DS. Then you've got the mainframe body, which is between 0 and 2312 bytes, and it contains the information based on the type and the subtype field in the FC field of this frame. And lastly, students, we have got the frame check sequence, and it contains the famous all-time favorite CRC32 error detection sequence. Now, students, we have got 3 different frame types that are defined by IEEE 802.11 standard. The first type of frames is called the management frames. Second type is a control frame, and the third type is the data frame. Students, the management frames are used for initial communication between the access points. Your control frames are used for the initial request to send, for example, or clear to send, and your acknowledgements and stuff. And then the data frames carry the actual data and some of the control information as well. Students, in the case of control frame, as you can see in the slide, we have got an RTS frame. The first bit, once again, is your FC bit, which is of 2 bytes. Then you've got a D bit to send the network allocation vector for all the other impacted stations. Then you've got address bits, and then you've got the FCS. So the CTS and the acknowledgement the acknowledgement frame, they look exactly the same. You've got an FC, once again you've got a D, then you've got an address, and then you've got the frame check sequence. So since the value of the subfields in the control frames, the subtype 1011 is the RTS. If the subtype is 1100, it's your clear to send, and then the last one is 1101, which is your acknowledgement. Students, lastly, we have got the physical layer for the IEEE 802.11 standard, and all the different implementations that we have got for the physical layer, except the infrared, they fall under the industrial, scientific, and medical, or the ISM band. And students, it uses 3 unlicensed bands in 3 ranges. The first one is 902 to 928 megahertz. The second one is 2.4 to 4.8 gigahertz. And the last one is 5.7 to 5.8 gigahertz. Students, as you can see, these are the specs for our physical layer in the IEEE 802.11 standard. The first one, which is the original one, is your 802.11. The techniques used are frequency hopping spread spectrum, DSSS, direct sequence spread spectrum, and in the case of infrared, there is nothing. And then you've got the modulation techniques used for each one of them, and the maximum achievable data rate of them. Students, we go all the way from 802.11a to N. As you can see, the most current is OFDM. We have got an achievable data rate, a band of 5.7 to 5.8 gigahertz. We've got multiple modulation techniques in this case, and there are implementations which are capable of achieving 600 megabits per second using 802.11n. I don't think there are any 802.11gs that are left in the modern implementations. Most of the implementations of the Wi-Fi or the wireless local area network or wireless Ethernet that we have today, they are all 802.11n using orthogonal frequency division multiplexing as the multiplexing technique.